Now you know substances including elements are the compounds, elements and the compounds, the 7th standard, isn't it? When did you read the elements, compounds and mixtures? 7th standard. What is the difference? Don't worry, I will not ask you any question. Where it's going to be element or a compound, here substances can be classified into based on the magnetic behavior of the substance. Magnetic behavior. They are classified into paramagnetic and diamagnetic. Paramagnetic influenced by the magnetic field, external field. Not influenced by the magnetic field, diamagnetism. You have a magnetic flux and try to send a diamagnetism, it is not going to be disturbed at all. There is no deviation in the path of the thing. You have external magnet tube, let us say, north pole and south pole. You try to pass. If it is a diamagnetic substance, there is no change in the deviation of the path. If it is a paramagnetic substance, definitely it is going to be attracted either by this pole or that pole. There is a change in the path. Such substances are called paramagnetic substances. The paramagnetic substance is due to the presence of one or more unpaired electrons. What is a paramagnetic substance? Presence of one or more unpaired electron. Because every electron has got a tiny magnet, considered to be a tiny magnet. Every electron. If you have got an odd electron, single electron, definitely. If you got 2 electron, 2 unpaired electron, magnetic property is more. So what is the point to be highlighted? Higher the number of unpaired electron, greater the magnetic property.
Can you repeat the definition?
Paramagnetic substances are substances influenced by the magnetic field, external magnetic field. There is a deviation in the path, deviation in the path, whereas not influenced by the external magnetic field. Diamagnetic substances are not influenced by the external magnetic field. Helium, neon, argon, krypton, xenon, radon, etc. There is not a single unpaired electron. They are not going to be deviated at all. Therefore, all of them are considered as diamagnetic elements. Diamagnetic elements. Whereas sodium, 1 unpaired electron, 281. Paramagnetic. Sodium chloride is diamagnetic. Sodium is paramagnetic, chlorine is paramagnetic, sodium chloride is diamagnetic. Account for NCERT question. Write it. Sodium and chlorine are paramagnetic elements. Sodium and chlorine are paramagnetic elements, while sodium chloride is diamagnetic. Sodium chloride is diamagnetic. Chemical bonding, we enter into chemical bonding slowly. I will not be doing individually the periodic table, individual electronic configuration, individually chemical bonding. Whenever I need, I have to combine all the 3, I told you. Sodium, 281, or you can write the orbital structure, 3s1, 1s2, 2s2, 3s1, 2p6, 3s1. And chlorine has got, how do you write it here? Na, no, you know how to write the 2, 8 and 1. And sodium can lose an electron always instead of accepting 7 electrons. What is the driving force of the elements to undergo a chemical reaction? Attainment of the octet. The octet can be obtained by losing this lost electron or accepting 7 electrons. But the energy consideration tells you that it's easy to lose a single electron. Therefore, sodium is always considered an electropositive element. Chlorine on the other hand, is considered as an electronegative element. The electronic configuration is 2, 8 here and 7 here. There are two ways of getting the octet here, either add one electron to that or remove all the 7 electrons. It's always easy to add one electron, therefore chlorine is considered as an electronegative element. In general, more than 4 or less than 4. How do you consider, given an atomic number x, I give you some 54, 58, some number there, and find out whether it is going to be electropositive element or electronegative element. You write the electronic configuration, see whether you have got more than 4 or less than 4. If it is less than 4, it is electropositive. If it is more than 4, electronegative. 4, of course, they do not form ionic compounds, they form covalent compounds. We are talking about the ionic compounds. Make a note of it, make a note of every point. What did I tell you? Write it, whatever you heard, please write it, let it go. Therefore, what happened? Sodium is highly reactive. The moment you bring a sodium here and chlorine here, instantaneously it is going to be very rapid, because sodium is just waiting for an opportunity to lose an electron. It is always looking forward, a person who is interested in accepting this electron. Helium comes here, helium says no, I do not want. Argon, neon, krypton, I am happy with the octet configuration. So you look forward to some other element. Now this chlorine comes, he is able to see fluorine, chlorine, bromine and iodine, and it is able to remove, transfer that electron, and transfer of an electron is known as ionic bond or electrovalent bond, isn't it? Therefore, after transference, don't you think it has got Na plus here and this has got Cl minus here? Write the electronic configuration. How many unpaired electrons in Na plus? What is the electronic atomic number? 10. What is the 10 atomic number? Neon. Neon has no unpaired electron. What is the electronic configuration of atomic number of chlorine? 17. After accepting, how many electrons? 18. It has got argon structure. Therefore, sodium chloride has no unpaired electron. It is diamagnetic in nature. How many of these different examples, 5 examples, have got the same unpaired electrons, same number of unpaired electrons? Did I say unpaired electrons? Yes. Now you have to say all the 5, only 4, only 3, only 2 or 1. The number of unpaired electrons in bromine? 1. Neighbor? 4. You tell me. 1. Neighbor? In Cr plus, how many? You tell me. 5. Number of unpaired electrons in scandium? 1 or 0? What is scandium? What is the electronic configuration? 3d1, 4s2. 4s2, electron, 1 electron is going to be removed from the 4s2 only. So it becomes 3d1, 4s1. Scandium 21. As per the Aufbau principle, 3d10, 4s, 4s2, 3d1. So it has to be written as 3d1, 4s2. Scandium has lost only 1 electron because it forms a positively charged species. The 1 electron has to be removed from the last one. That is why we write this way. Therefore, the electronic configuration is 3d1, 4s1. Therefore, 2 unpaired electrons. 2 unpaired electrons. So, how many of these species, now you know the single digit answer, how many of these different species have got the same number of unpaired electrons? Only 2. Only 2. Or it could be asked in the form of a multiple choice question. I will solve this A, B, C, D, E, etc. A and B, A and C, B and C, D and E, all of them or none of the above. Now you know the answer. Now you know the answer. Is that clear to you? The number of unpaired electrons in this. Now, are there any doubts up to this point? Another question. Another question. Name one element that known to you, element having maximum number of unpaired electron, magnetic moments, paramagnetic property, which has a maximum paramagnetic behavior. Name the element that we have seen today. For that you don't need to refer to your earlier, what are all the elements, that's going to take a longer time here. Good. Chromium. The electronic configuration is 24. I said 4s2 3d4, but it has to be 3d5 4s1. How many unpaired electrons? 6 unpaired electrons, 5 in the d orbital, 1 in the s orbital, right? Make a note of it. 5 in the d orbital and 1 in this, and that is going to be 3d5 4s1 maximum. Now, I did not explain to you why half-filled orbitals are more stable. The most stable is completely filled orbital. You don't require any explanation for that. Do you require an explanation? Why not? I am asking you indirectly other way, why completely filled orbital is the most stable orbital?
It needs no.
There is no unpaired electron. The reactivity of an element is due to the presence of one or more unpaired electrons. Reactivity highlighted, point to be highlighted. What is the point to be highlighted? Shall I write it for you? You write it then. Reactivity of an element is due to the one or more unpaired electrons. Is that okay? Right. Therefore, completely filled orbital is the most stable. We shall take up half-filled orbital. Why this is going to be more stable? Why we don't consider S1? I told you S1 is not to be considered as half-filled orbital. Then what is half-filled orbital? And what is the reason for the greater stability? Let me take P3 orbital. Let me take a P3 orbital, D5 orbital, and F7. So whatever explanation I hold good, the same explanation holds good here also. Now let us see. As per the Hund's rule, there are 3 unpaired electrons. I will call number them electron 1, electron 2, electron 3, electron 3. I have labeled them, I have given a name. They can be identified. What happens? They too don't remain in the same house, same room. They keep changing. They exchange, 1 and 2 exchange. 1 and 3 also they exchange rapidly. It is not going to remain px. Where do you find that single electron x? It could be px orbital, py orbital, pz orbital, because it keeps changing. Then these two also can change. Why should they change? When they change their place, energy is given out, and that energy is called exchange energy. That energy is called exchange energy, and that is exothermic reaction. Are you with me when I say energy is reduced, stability increased? Do you agree with me? As the energy decreases, stability increases. Yes, I am more energetic, I want to do lots of things, and when the energy, keep this is going to be, it has got some potential energy, let anything, whether potential energy or chemical energy, kinetic energy. Now slightest disturbance, I do the same slightest disturbance, will it go and stand on its own? No, it goes more stable. Why is it more stable? Energy is less. Anything which comes from the higher energy level to lower energy level, stability is increased. Stability is increased. And what happens when it does so? Exchange, energy is given out. And greater the exchange of the electron, greater the stability. Therefore, now you know the answer for one question. Between p3 orbital which is half filled and d5 orbital which is half filled, which will have a greater exchange energy given out? d5 orbital. 5 electrons are exchanging among themselves, 1 and 2, 1 and 3, 1 and 4, 1 and 5. How many exchange energies are there for? Calculate. How many exchange energies you have got? 1 and 2, 1 and 3, 2 and 3. There are 3 exchange energies. And d5, put it 1 and 2, 1 and 3, 1 and 4, 1 and 5, 2 and 3, 2 and 4, 2 and 5, 3 and 4, 3 and 5, 4 and 5. How many did you get? So when 10 electrons exchange their places, more energy is given out. Therefore, d5 orbital has got a greater exchange energy than p3 orbital, obviously F7. Now why should they lose energy? Anything when they exchange their places, exchange of place is equivalent to delocalization. A very, very, very important concept we will be using repeatedly in organic chemistry. And the point to be highlighted, greater the delocalization, greater the stability. Delocalization leads to greater stability. Delocalization leads to greater stability. I should give an example for you to understand this. I have a target, a bigger one, wider one. You are all expert in throwing the chalk piece. Hit it. It should come and hit. Or to help you, I will have a broader one, 1 foot by 1 foot. All of you, definitely, you can hit it. The chances of hitting this target is more. Now, second option, I keep moving this. How many of you are going to hit this? Moving target and fixed target. It is a fixed target. It can be easily be attacked. Moving target, which is going to be more stable? Moving target. Why is it more stable? It is localized, whereas this is going to be delocalized, not remaining in one place. That's the reason, maybe for me also, for you, you don't want to be in the same posture all along. 3 hours I stand here and keep saying everything. It's not possible. It's going to be monotonous, isn't it? Boredom. So I change the variation of the tone, delocalization. I keep moving, there is a delocalization. I move my hands, delocalization. Because every one of my act I want to have greater stability. Greater the delocalization, greater the stability. And what happened? As long as it is going to be there, it can readily be easily be picked up. I told you, no? And now electronegative element can pick up this. Now it does not want to be, it wants to be greater stability. Therefore, that particular element keeps changing. Therefore, greater the exchange energy, greater the stability. Therefore, half-filled orbitals are more stable than any other configuration. Supposing what is going to be, I will give you another question, very simple question for the IIT level. Arrange the d orbitals, arrange the p electrons, arrange the p electrons. What are the p electrons? P1, P2, P3, P4, P5 and P6. How many configuration? P1 to P6. Arrange them in the decreasing order of stability. Arrange them in the decreasing order of stability. Most stable, P6. The next one, P3. The next one, all of them. And among them, of course, there is a variation. We will put them together for the time being. What are the other configuration? P1, P2, P4, P5. And there is a difference in the stability also. Between P1 and P2, which is going to be more stable, which is going to be more reactive? P2 is going to be more reactive. Why? 2 unpaired electron. I told you reactivity. What did I tell about the reactivity? Greater the number of unpaired electron, greater the reactivity. So between P1 and P2, P2 is more reactive. And between P4 and P5, tell me. P4, how many unpaired electron? 2. Between P2 and P4, more or less the same. More or less the same. But of the two, P4 is likely to be more reactive than P2. That is what I am going to explain to you. While considering the reactions, electronic configuration of boron, carbon, it is a time for me to talk about those elements which I have just left it just like that. And that whatever you are going to say P4 and P2, that holds good in these cases also. Electronic configuration of boron. Please write it. 1s2 helium. Henceforth you should say only condensed electronic configuration. Helium 2s2 2p1. Let me take beryllium also simultaneously. Helium core 2s2. How many unpaired electrons? Which is more reactive between beryllium and boron? Why? Boron has 1 unpaired electron. What is the valency of boron? Number of unpaired electrons? 1. But unfortunately, we don't have a single compound with valency 1. All the compounds of boron exhibit valency 3, BCl3, BF3, boron nitrate, boron BOH thrice, it is called orthoboric acid, H3BO3. You are going to study all these things. Boron has got valency 3, not 1. Beryllium, what should be the valence of beryllium? 0, as per the Aufbau principle. But beryllium forms lots of compounds. Beryllium chloride, beryllium forms BeCl2, make a note of this. Beryllium oxide, BeO. Beryllium nitride, what should be the formula of beryllium nitride? Be3 N2. Be3 N2. Beryllium nitride. Beryllium sulfate, BeSO4. Beryllium nitrite, nitrite you can say, nitrite, Be NO, NO2 twice, nitrite. What is phosphate? Beryllium phosphate. I will ask you next class when you come here, Be3 PO4 twice. When you come here, I will give you 15 compounds, you have to write the formula. Just like that, using all sorts of anions and cations I know available. I will be saying perchlorate, hypochlorite, bromate. Let's see how many of you are prepared for this. Anyhow, maybe I will just stop with this. The valency of beryllium is 2, valency of boron is this. Another very interesting example, carbon. What is the carbon here? 6. Helium nucleus, and tell me, 2s2 2p2. As per this, what should be the valency of carbon? 2. The only example of carbon exhibiting valency 2 is CO, carbon monoxide. Make a note of it. You still have some in all the other compound, what is the valency of carbon? 4. Carbon is tetravalent. Now, these 3 cases, boron, beryllium and carbon, they always make use of excited state configuration. I am just going to leave with that, that is all. What is the excited state configuration? Look at this, s orbital, fill, and p orbital. There is only 1 electron here. To account for valency 3, I should have 3 unpaired electrons. How do I have an unpaired electron? I uncouple this electron over here and is promoted to the orbital here. Therefore, I will be getting 2s1 2s1 and 2p2. Now, in this case, are you not convinced that you have got 3 unpaired electron here? That is the configuration of boron, 3 unpaired electron. Similarly, how do you account for this? 2s orbital is full. Please remember, at the second level, you have the 2p also. In order to account for 2 unpaired electron, and this pair is uncoupled, is promoted to, what should be the electronic configuration of beryllium plus here? It is going to be 2s1, 2p1, 2p1. It comes over here. You have only one electron here. It's promoted over here. Same way, what should be the electronic configuration of excited state carbon here? Tell me. 2s1, 2p3. So how many unpaired electron? 4 unpaired electron. Therefore, is that clear to you?